Okay, here we go with number 47. So we've got a parabola, and notice that the x is squared, not the y. So we know this is going to be either opening up or down. So we'll first rewrite it into standard form. So we're going to do that by adding the 16 times the quantity y plus 1. Or y minus 1. So the distance between the vertex and the focus, as well as the vertex and the directrix, is p. So in this equation, p is equal to 4. Our vertex can be found by looking at the equation. -2, 1. So since p is 4, we know it's 4 units away from the vertex. So I go up 4, and there's my focus. So my focus is at -2, 5. Now I know it's above and not below because p is positive, meaning that it's opening upwards. And the directrix is going to be 4 units away from the vertex. And that has the equation y equals -3. Okay, number 48. Find the center, vertices, foci, and eccentricity of the ellipse, and then sketch its graph. Now, we didn't really talk about eccentricity here, so we're going to go ahead and not worry about it. Okay, so the center is going to be at 0, 0. Then, the vertices are on the major axis, which is going to be along the vertical axis because the 225 is bigger than the 81. So the square root of 225 is 15. So that means we're going to go 15 units in the vertical direction. I go by 2's here. Okay. And then for horizontally, we're going to move 9 units. So the vertices are along the major axis. So we've got 0, 15, and 0, -15. Now, for the foci, they lie along the major axis. So for an ellipse, c squared equals a squared minus b squared, where c is the distance between the center and each of the foci. So my a is 15, my b is 9, so when I subtract, I get 144, which means c is equal to 12. So the foci are 12 units away from the center. So the foci are at 0, 12, and 0, -12. Okay, so 49, we have a hyperbola. We know it's a hyperbola because of the minus sign here. So the center of the hyperbola is going to be at -1, -2. My A is the square root of 4, or 2. My B is the square root of 16, or 4. Okay, so these values are going to help me graph the hyperbola. So here's my center. So since the a squared is under the y, I'm going to go 2 units away in the vertical direction, and then 4 units away in the horizontal. So these I'm going to make my box. Then the asymptotes are going along the diagonal of the box. Okay, then to draw my curve, I have to decide, am I going to use these 2 points or these 2 points? Well, looking back at the equation, the y squared part is positive, so we're going to choose the vertical. So our vertices are these 2 points here. So we've got -1, 0, and -1, -4. Now, for the foci, we have to figure out c. In a hyperbola, c squared is equal to a squared plus b squared. So here, c squared is 20. So c is 2 radical 5. So the foci are going to be 2 radical 5 units away from the center, which is about 4.5 units. So my foci are going to be at -1. Then we have, we start at -2, and we're adding 2 radical 5 units. And then same thing here, but then we're subtracting 2 radical 5 units. And those are the foci. Now, the question asked for the asymptotes, so I'm not going to probably ask for an equation on the semester final exam, but you just find the slope, find a point on the line, and just write the equation in point slope form. Okay, last question. I'm supposed to classify it as one of these equations. So if it was a parabola, only one of the variables would have been squared, either x or y. In this case, they're both squared, so it can't be a parabola. We look and we see we have a minus 5y squared. So that tells us it's a hyperbola. If this was 2x squared plus 5y squared, then it would be an ellipse. If it was plus and these numbers, the coefficients were the same, then it would be a circle.